The Fermi Paradox. Enrico Fermi sat down for lunch at Los Alamos in 1950 and asked a question so simple it became a crisis. The universe is roughly 13.8 billion years old. Our galaxy alone holds somewhere between 200 and 400 billion stars. Even with conservative math, civilizations should have had billions of years to spread, signal, and colonize every corner of the Milky Way. So where is everybody? That single question at a lunch table became the most uncomfortable open loop in all of science. The design of the problem is elegant and brutal. If life emerges even rarely, the sheer age of the cosmos means someone should have beaten us here by millions of years. The cost of silence is enormous. It either means we are impossibly alone, or something keeps intelligent life from surviving long enough to be heard. Fermi never published a formal paper, but the question outlived him, and no one has closed the loop since. The Great Filter. Picture a long corridor with doors. Most civilizations never make it through. The Great Filter, first formalized by economist Robin Hanson in 1998, is the idea that somewhere between dead chemistry and galaxy-spanning civilization, there is a barrier. Almost nothing survives. The terrifying pivot is this: we do not know which side of the filter we are on. If the filter is behind us, things like the jump from single cell to complex life may be the rare miracle, and we somehow made it through. If the filter is ahead of us, then every civilization that reaches our level eventually destroys itself. The enemy pressure here is not a government or a rival, it is probability itself. Every discovery of simple microbial life on Mars would actually be devastating news, because it would mean life starts easily, the early filters are weak, and the hard stop must be waiting somewhere ahead of us. The Rare Earth Hypothesis. Stand on the surface of Earth and look at what it took to build this place. Peter Ward and Joe Brownlee laid it out in their 2000 book with surgical precision. Earth sits in the habitable zone of a stable star. It has a large moon that steadies its axial tilt. It has a giant like Jupiter clearing debris from the outer solar system. It has plate tectonics recycling carbon. It has a magnetic field blocking lethal radiation. The argument is that complex life does not just need liquid water. It needs dozens of conditions stacked perfectly at once. The daily mechanics of this theory are almost claustrophobic. The more conditions you add to the list, the smaller the probability becomes. The collapse of the optimistic view happens right here. What looks like a universe teeming with possibility may actually be a universe full of sterile rocks, with Earth as a statistical accident so extreme it borders on miraculous. The dark forest theory. Liu Cixin introduced the framework in his 2008 novel, but the logic underneath it is coldly rational. Every civilization in the universe knows two things: resources are finite, and survival is the only goal. In a universe where you cannot verify another species' intentions, the safest move is always to destroy the other first. The design is a prisoner's dilemma with extinction as the penalty for guessing wrong. The operational mechanic is silence as camouflage. Any civilization that broadcasts its location is painting a target on itself. The pivot that makes this theory genuinely unsettling is the implication for us. We have already been broadcasting radio waves for over a century. If the dark forest is real, we announced ourselves decades ago. Enemy pressure in this framework is invisible and omnidirectional. The crackdown may not come as a warning. It may come as nothing at all, and then silence of a different kind. The zoo hypothesis. Imagine a nature reserve. Now imagine you are the animal inside it, and you have no idea the fence exists. The zoo hypothesis, proposed by John Ball in 1973, suggests advanced civilizations are deliberately avoiding contact with us, watching from a careful distance, allowing us to develop without interference. The design mirrors every prime directive in science fiction, but Ball meant it seriously. The operational question is who coordinates the quarantine. For it to hold, every advanced civilization in the galaxy would have to agree not to make contact. One defector ruins the whole arrangement. The cost of this theory is existential in a quieter way. It means we are observed, catalogued, and considered not yet ready. Arthur. Pivot is the enforcement problem. Silence across hundreds of civilizations requires a level of coordination that strains credibility. And yet the alternative explanations are not obviously more comfortable. The self-destruction filter. Pull up every existential risk on a single screen. Nuclear war, engineered pandemics, runaway artificial intelligence, climate collapse. The self-destruction theory argues that intelligence itself is the fatal adaptation. The design is almost ironic. The same cognitive leap that lets a species build radio telescopes also lets it build weapons capable of ending everything. Carl Sagan wrote about this tension in the 1980s with genuine alarm. The daily operational mechanic is familiar because we live inside it. Every decade that passes without catastrophe is a narrow escape, not a guarantee. The enemy pressure comes from within the civilization itself. Competing factions, ideologies, and incentives pull towards short-term power rather than long-term survival. The collapse scenario needs no outside force. The filter is built into the architecture of intelligence, and the question is whether any civilization ever figures out how to dismantle it before it fires. The Simulation Hypothesis. In 2003, philosopher Nick Bostrom published a paper arguing that at least one of three things must be true. Civilizations go extinct before they can build realistic simulations. Advanced civilizations choose not to run them, or we are almost certainly living inside one right now. The design of this theory is recursive and vertiginous. If simulated universes vastly outnumber real ones, then statistically, base reality is the rare exception. The operational implication for the Fermi Paradox is sharp. There are no aliens because the simulation was not programmed to include them at our resolution level. The pivot is that this theory is nearly impossible to falsify, which makes it either the most profound idea in science or a very sophisticated dead end. Enemy pressure takes the form of physicists who point to the computational cost of simulating quantum-level reality. The crackdown on this idea keeps failing because the math refuses to fully collapse it. The communication gap. Imagine trying to explain the internet to a Roman soldier. The communication gap theory argues that advanced civilizations may be broadcasting constantly, but we are simply not recognizing the signal. In 1959, Giuseppe Cocconi and Philip Morrison published a paper suggesting we listen on the 1420 MHz hydrogen frequency. We have been listening on narrow bands ever since. The design assumption is that aliens would use radio waves the way we do. But a civilization a million years ahead of us might communicate through methods we have not yet theorized. The daily mechanic of SETI has always carried this vulnerability. We are searching with the tools we understand. The pivot is the 1977 WOW signal, a 72-second burst from the direction of Sagittarius that matched the predicted profile of an extraterrestrial transmission and has never been explained or repeated. The crackdown on optimism comes from the silence that followed, decades of listening and one anomaly that refuses to resolve. The interstellar distance problem. Light takes 4.2 years to reach the nearest star. It takes 100,000 years to cross the Milky Way at that speed. The distance problem is not a theory so much as a physical wall. Even a civilization that wanted to colonize the galaxy would face travel times that dwarf the entire history of human civilization. The design of the cosmos seems almost deliberately hostile to contact. The operational mechanic of interstellar travel at any realistic speed requires energy budgets that are staggering. A probe traveling at 1% of light speed would take 420 years to reach Alpha Centauri. The cost is measured in millennia. The pivot is that some physicists take concepts like the Alcubierre warp drive seriously as mathematical objects, even if the engineering remains fantastical. Enemy pressure comes from thermodynamics and the inverse square law, which weaken every signal over distance. The crackdown is simple. The universe may be full of life that simply cannot reach across the gap in any meaningful time frame. The short window problem. A civilization capable of radio transmission may only exist in that form for a few hundred years, before either destroying itself or evolving into something that no longer uses radio. We have been broadcasting for about 120 years. The design of this theory treats technological civilizations as brief sparks rather than permanent beacons. The operational math is sobering. If every civilization only transmits for a few centuries, the probability of two civilizations overlapping in both time and detectable range collapses dramatically. The pivot is the realization that we might be searching for a window that opens and closes faster than we can find it. Enemy pressure comes from our own trajectory. Within decades, we are already shifting from omnidirectional broadcasts toward tight beam transmissions that leak almost nothing into space. The crackdown on our own visibility is already underway, and we are doing it to ourselves without even trying. The Planetarium Hypothesis. In 2001, Stephen Webb described a scenario where an advanced civilization has constructed a false sky around us, a perfect illusion of an empty universe to keep us isolated. It sounds like science fiction until you sit with the logic. The design requires a civilization so far beyond us that engineering the observable universe around a single planet is within reach. The operational mechanic is unfalsifiable almost by definition. If the illusion is perfect, no instrument we build can see past it. The cost is epistemological. It means our entire picture of the cosmos could be a stage set. The pivot is that this theory is philosophically indistinguishable from the simulation hypothesis at certain angles, which either strengthens both or undermines both. Enemy pressure comes from Occam's razor. The simplest explanation rarely involves a galaxy-spanning deception aimed at one species on one pale blue dot. But the simplest explanation has been wrong before: the Transcension Hypothesis. John Smart proposed in 2012 that advanced civilizations do not expand outward into space. They expand inward into miniaturization, virtual reality, and inner complexity. The design argues that the most efficient use of energy and matter is not a Dyson sphere, but a civilization that compresses itself into smaller and denser computational substrates. The operational mechanic means advanced life becomes invisible, not because it hides, but because it shrinks below our detection threshold. The cost of this theory is that the search for alien megastructures across the galaxy may be looking in exactly the wrong direction. The pivot is that it reframes the silence not as tragedy or threat, but as a natural developmental stage. Every civilization graduates from radio waves to something we cannot yet imagine, and simply disappears from our instruments. Enemy pressure comes from the fact that we have no confirmed examples and no way to test the hypothesis directly. But the crackdown on the idea keeps failing because nothing in physics rules it out. The silence of the universe is not one mystery. It is 12 competing mysteries wearing the same face. Each theory reveals a different assumption about what life is, what intelligence does, and how long either survives. The most unsettling part is not that we might be alone. It is that every explanation for the silence, from filters to forests to illusions, tells us something specific and uncomfortable about our own future. The question Fermi asked over lunch is still open, and the answer, when it finally comes, will almost certainly change everything.